All right, so in this last example, we're asked to find the area of the triangle with side lengths 11, 17, 20 centimeters. Round your answer to the nearest tenth. And it's asking us to do it in two ways, okay? Using the law of cosine and then using Heron's formula. I'm going to use law of cosine first, and then I'll explain Heron's formula with you in a minute here. Okay, so they don't give you any labeling or letters here. You can just draw a triangle however you want to draw it, as long as you label it correctly. So I'm just going to draw some triangle here. And I'm just going to randomly label it triangle ABC. And we'll call this little b, little c, and we'll call it little a. Okay, so for no other reason, I'm just going to call this side 17. This guy right here, we'll call it 11. And then little b, I'm just going to randomly call it 20 cm. Okay, so however you want to draw your triangle, however you want to label it. Okay, so to compute the area of the triangle, right, let's think about how do we find the area of the triangle? It's 1/2 base times height, right? And in this case, we already have the base. I'm going to call this my base. My base is 20. Oops, not 200. The base is 20. And all I need is my height, right? Question mark. Once I have my height, I can figure out the area of this triangle, okay? Now, it says use the law of cosine, right? Because in order for us to use the law of cosine, we need to figure out either this angle or this angle, because I'm going to call this the base. And then we can just take the sine of this particular angle, drop down the height, and figure out what the height is. Okay, once we have the angle measurement of angle A or C, it doesn't matter, you can plug it in and then you'll get the area. Okay, all right, so let's figure out what angle A is. I mean, if you want to figure out angle C, that works as well. So if I want to figure out angle A, right, you're going to use the fact that little a squared is being isolated. So I'm going to say little a squared is equal to b squared plus c squared minus 2bc cosine of angle A. And just like I did in the previous video, right, you need to get angle A by itself. So a squared minus b squared minus c squared, right, divided by negative 2bc is equal to cosine of angle A. Okay, so you move these two terms over. Because this is being multiplied, you divide by negative 2bc. Again, you could put the negative at the bar if you want. All right, so to get angle A by itself, right, you take the cosine inverse. So A is the cosine inverse of little a squared, which is 17 squared, minus little b, 20 squared, minus c squared, 11 squared, all over negative 2bc. Okay, negative 2 times 20 times little c, which is 11. All right, so if your calculator can't enter all this in one line, I would just, to enter all this, whatever this is, you're going to get some kind of decimal. I believe it's 0.527. Okay, so if you were to enter this, this is about 0.52727 dot, dot, dot. If you can't enter all this in one line, just, take it one step at a time. Okay, so if you take the cosine inverse of this number, you're going to get 58.17. I'm going to round to the nearest hundredth. Let's call it 58.18 degrees. And now that you have this angle, right, you can label it. It's 58.18 degrees. You can now find the height of this triangle. Okay, how do I find the height? You would say sine of angle A, which is 58.18. Sine of this angle opposite of a hypotenuse. Okay, so you're not using law of sines, you're just taking using right triangle trick, right? Sine of 58.18 opposite h over 11. Okay, so now that you have the height, right, h is 11 sine 58.18. You take this value right here, right, and then you plug it in. Okay, so your final area when you do that is going to be approximately 93.5 cm squared. Okay, so all your all area units are going to be in units squared. Okay, in this case, they gave us the units, which is centimeters squared. Okay, so way one is actually the long way of doing this problem, right? But it's using knowledge that you've acquired before if you watched the previous videos on, dropping down the height. By the way, I mean, if you look at your textbook in 9.3, they gave you 3 different formulas to find the area of a triangle. It's basically what I showed you over here, okay? But there's no need to memorize it as long as you just drop down the height and then, figure out the sine of this angle or this angle right here if they give it to you. And then come up with an expression. So there's no need to memorize, all these 3 different area formulas if you know right triangle trig. Okay, so way 2 is using Heron's formula, and that's a new concept, but it's really, really straightforward. Again, the derivation of this formula is, it takes a long time, so there's no need for me to derive it. Definitely, if I'm not deriving the other formulas, there's no need to derive this one. Basically, you take the square root of s times s minus a, s minus b times s minus c, and s is your semi-perimeter. Okay, semi just means half, right? So you take the perimeter and divide by 2. And so this is just a straight plug-in. Okay, so the semi-perimeter in this problem right here, 11 plus 17 plus 20. So 11 plus 17 plus 20, I need to calculate that, divide by 2. And looks like you're going to get 48 divided by 2, which is 24. That's your semi-perimeter. And then you plug it in. Okay, so 24 times 24 minus 11 times 24 minus 17 times 24 minus 20. Okay, so this one is not much thinking involved, right? You're just using the formula. And you should get the same answer. It's approximately 93.5 cm squared.